Let us look at motion under gravity. Okay. Now, at first we are talking about linear motion. We said this is a motion that actually is on a flat surface, and we are finding acceleration. In this section of motion, we are going to talk about objects that we throw up or that freely fall due to gravity. Now, this is the vertical motion. The other one we were talking about was horizontal motion. Okay. So, the equations remain the same. That's the first thing that you need to know. The equations remain the same, and the only few things change. So in linear motion, we had the velocity is equal to ut plus no, that was not the first one. U plus at, this was the first equation. The second one we wrote this one, ut plus half at squared. And the third one we wrote was this. Okay. Now, motion under gravity is simply the same thing, but the only difference is that now acceleration becomes the acceleration due to gravity. So acceleration here transforms to g. And we know that g is 9.81 meters per second squared. So under motion due to gravity, we literally have no need to find acceleration because we know that acceleration is 9.81. So these equations simply transforms to g, simply transforms to g. And this s, excuse me, this s becomes the height because now we are talking about something that is up. So it's a height. Okay. We are no longer talking about this distance, but you can leave it as s. You can leave it as s instead of changing to h. It doesn't matter. What we really wanted to mention here is the acceleration becomes 9.81. And the same rules apply. Collect the data, look at which equation that we are going to use. Then you go on and solve. So let's say I'm throwing a stone all the way up. Then when it reaches there, it comes down. This is my ground. So I'm throwing this stone up. It reaches the maximum height there, then it starts coming down. There are a few things that you need to understand here. When you are throwing the stone up, you are giving it the push. It's you who is giving it the push. So the initial velocity here, it's going to be maximum. It can't be zero because you have to overcome gravity. So as it moves, the velocity is actually reducing. At the maximum height, the final velocity is zero. It has to stop, then it starts coming down. So remember this. It starts with a good velocity, initial velocity. It goes all the way. The time it reaches the maximum height, it will stop, then begin coming down. So there is that. So final velocity here, when it's going up, it's zero at the maximum height. When it begins to come down here, initial velocity is zero, and the final velocity here will be maximum. So you should remember this if you have to solve acceleration due to gravity equations correctly. When you are throwing something up, the velocity is given always. Not that it's given as a number. It's some velocity. That's what I mean. It has got magnitude. When it reaches the maximum height, it becomes zero. Then the object is going to stop for a moment and it starts coming down. When it starts coming down, the initial velocity is zero because it's a free fall. Then the final velocity here will be maximum. The second thing that you have to notice is we neglect air resistance here, meaning the velocity with which you throw it up with here, it will be the same velocity that it reaches down with here. So all that. So you can find the height here and the time it takes to go up. If you are told to find the time it takes to come down, just find the time it takes to go up and multiply by 2. It will still be the same time. We neglect air resistance. So those must be noted. Number 2, acceleration is a vector quantity. So you need to give it some direction. You can't just say when it's going up it's 9.81, when it's coming down it's 9.81. You need to define your Cartesian graph here. So for example, in our case, what we are going to use is when the object is going up, we are going to take acceleration is going to be negative 9.181 meters per second squared up. When it's coming down, gravity will be positive 9.81 meters per second squared. So we just need to define this so that we don't get mixed up. All right, so we can move on in that direction, solve some questions, then we call this a rest. Yeah, so there's an example here which we can solve. A stone is thrown vertically upwards with a velocity of 28 meters per second. Find the distance it will cover in 2 seconds. So we have got a stone that is thrown vertically upwards, and definitely at some point it's going to come down. That's the truth, as long as there's no one who is catching it up there. So it has been given the initial velocity of 28. And they are asking us to say at a certain distance here, it should have covered some distance in 2 seconds. So they are asking us to find that distance. Now, we still use the same thing. We collect data. We say initial velocity is equal to 28 meters per second squared. Final velocity we are not given. Okay, then we are asked to find the distance, whilst we are given time to be 2 seconds. Okay. Now, from the equations of motion, you can tell which one you can use. Okay. Number 1, we only use the one without final velocity, which is AC is equal to UT plus half GT squared. Now, I have replaced A with G. And because it's going up, my gravity is going to be 9.81 meters per second squared negative. It's going up. Remember what we defined. So we can simply solve this one. Okay, so let's go. AC is what we are looking for. We are looking for distance. Initial velocity is 28 multiplied by time is 2 plus half. Gravity is negative 9.81 multiplied by time is 2 seconds squared. Just put these into your calculator. Let me know what your answer is in the comment section. All right, so my answer becomes 36 point something. I haven't really calculated, so let me say 36.4 meters. Okay, so that is the distance that it will cover, and that's how you simply find these answers. Okay, now it's also in some books the sense that we have used is totally different. They use something else. So for example, us, we said when we are going up, gravity is negative 9.81. In some books, in some literature, you read it will be positive, but what they will do is they will take velocity going up to be negative, and the answer will still be the same. So it depends with what you take. In this lesson, we are using gravity going up as the negative. Then we leave everything as they are positive. Okay. So that's what you are expected to do. Go and solve a lot of questions. Find the books, find the past papers. Solve. You only learn by solving. As long as you don't do things by yourself, there's nothing that we are going to do, and you have got an assurance of failing. So get the concepts from what we are talking about, write these notes in your books, then get the past papers. They are there. Get to the library, they'll give you the past papers. I think there are quite a number of soft copy past papers. I think there's even an online library for past papers, Teveta past papers. Go solve them. Where you have a problem, consult from a friend. And then you'll be warm and dry.